A 15 ohm resistor and a 20 ohm resistor are connected in parallel with a 9-volt battery. A single ammeter is connected to measure the total current of the circuit. So the first thing they want us to do is draw a diagram of the circuit, and then after that they want us to find the equivalent resistance of the circuit. So let's do the sketch first. So we have a 9-volt battery, and we have a 15 and a 20 ohm resistor connected in parallel with the battery, and then there's an ammeter to measure the total current of the circuit. So let's start with the voltage source. It's usually a good idea. So the way they want you to draw the battery is like this. This is a very kind of a specific thing, but there's symbols in your equation sheet that say how to draw a battery, and this is how they want you to do it. So that's that, and then we'll go across. Alright, so that's our voltage source. Let's identify that. We'll call that 9 volts. 9-volt voltage source. And actually, I want to put the ammeter right in here, so I'm going to erase some of this stuff. And I want to put the ammeter right there. Alright. And then we'll drop down and we'll put one of our resistors right here. So that will be, let's say, the 15 ohm. And then we'll put another resistor right here. And we'll call that 20 ohms. And that's it. That's the sketch. We got a 9-volt battery. We got our two resistors in parallel, so the voltage across each of those resistors is 9 volts in both cases. And the current that's flowing through, this ammeter, because of where it's been placed, will pick up the full current. If you place the ammeter in one of the legs, in one of these two branches where the 15 ohm or the 20 ohm resistor are, then you'll only pick up part of the current. You have to either put it here right after the battery, or somewhere over here after the two legs have merged, somewhere downstream of this node, so that way you make sure to collect all the current. So that's the sketch. And then they want us to find the equivalent resistance of the circuit. Well, when you have resistors in series, you can just add their resistances directly, right? So if this was a series circuit, you could say 15 plus 20 is 35, so the total resistance is 35. But when you have resistors being added in parallel, the resistance actually goes down. Think about what that means. Because there are two choices for the way the current could flow, the total resistance of the circuit is actually less than either 15 or 20, because it could go this way or that way. So hopefully that makes intuitive sense. To actually calculate it, the formula is 1 over the equivalent resistance, which is what we want. This is what we want to solve for, is equal to 1 over R1 plus 1 over R2. And if there were more resistors in parallel, it would be plus 1 over R3 and R4 and so on. And we can either substitute directly in for R1 and R2 and work out the algebra, or we can do the algebra first and then make the substitutions. In this case, I'm going to do the substitutions right away and work out the algebra after. So we know R1 and R2 are 15 and 20, so we'll do 1 over 15 plus 1 over 20. And let's see if we can grab our calculator. There it is. So we're going to do 1 divided by 15 plus 1 divided by 20 is 0.11. Let's just I'll put this off to the side for a minute. So that's 0.116 repeat. Alright, and that's equal to 1 over Req, the equivalent resistance of the circuit. 0.116 repeat. So if we want to find Req, we could either cross multiply or we could just invert both sides. So this must mean that Req equals 1 over this. So in the calculator, I'm just going to do this, answer raised to the -1, which just basically flips it and inverts it. And we get Req equals we'll just round it off, say 8.6 ohms is the equivalent resistance of the circuit. And that satisfies the second question. So we got our drawing, we found the equivalent resistance, and the sketch is good. It's all done.